morning, Informal. Today we are going over symmetry. Kind of a little different change of pace compared to the last 2 days of this unit, but I think we all know what symmetry means, right? I always think of like a butterfly. It's like the same. Oh, here's a butterfly right here. Same on both sides, right? If you look at the wings, this wing over here mirrors this wing over there. But symmetry is all over us. It's all over architecture. It's all over nature. And again, if you look at the cat, I could split it like this. And the left side is a mirror image of the right side. Or this couch. And split it down the middle, and that's the same. Or this vase. Or this ladybug. You go like this. There's all sorts of kinds of lines of symmetry on this fruit. I could cut it so many different ways, and it's the same all over. Just like the snowflake and so on. If we look here, hopefully that building was familiar to you. That'd be good old Central. But yeah, like even our front entrance or the front of our building has symmetry. If we look down the middle, both sides are the same. Obviously architects know that symmetry is pleasing to the human eye, right? Like we kind of gravitate towards things that are symmetrical for the most part. So that's why it is so prominent in a lot of our architectures. I found this article that we're just going to look at real quick. I'm going to try not to talk so loud since I'm right by my computer. So if I'm blowing your ears out, I apologize. Gotta love a good old BuzzFeed article, right? So these are just celebrities. And right now, this is Iggy Azalea. Do you guys remember her? She had a few hits not that long ago. Well, maybe it was a while ago. Anywho, so this is what her face looks like normally. And if I move this little bar to the right, that's what her face would look like if it was just completely symmetrical with her left side or to the right. This one's kind of hard to tell, but we'll find some other ones here. Harry Styles. So this is what he looks like normally. Now if I move the bar to the left, this would be if his face was completely symmetrical to the left side. It looks pretty similar. So this is what he looks like again normally. And now to the right, it's, I don't know. Isn't that kind of crazy? Like he looks like it's still Harry Styles, but it's still different because this is normal. That'd be completely symmetrical. They say if your face is completely symmetrical, that you are the most beautiful. If you have a symmetrical face, I mean, that is like a golden rule of beauty. It's good old Queen Beyonce. This is what she looks like normally. I mean, again, like to us, like we don't see Beyonce every day. That looks like Beyonce to me. Or if we go to the other way, that looks like kind of like a weird version of her, but it's still Beyonce, right? Let's see a few more. Taylor Swift. Okay, this is what she looks like normally. Kind of weird. But this way, I mean, that still looks like Taylor to me. What about you guys? Let's see who else. Jennifer Lopez, little J-Lo. I don't think this is a very good picture because her mouth is going to mess it up, but to the right, to the left, still looks like J-Lo. Channing Tatum. He's a good dancer. Actor, oofed. Looks like him. Katy Perry, again normal. Slide it. It's kind of crazy. They all look like themselves, but still different. Ariana Grande, normal. Still looks like Ariana Grande. I mean, if we could get rid of like her hair situation up here, I feel like it'd look not so weird. Pharrell. Rihanna. I think the hair is really what throws it off, but she must have a very symmetrical face because I think hers is the best one yet. Like, look, there's hardly much of a difference. She must be considered beautiful. I think she's beautiful. Ryan Gosling. We could look at him all day, right? Oh, his hair. Look at his hair, you guys. Drake. Kind of looks like a skinnier version of him. And then like a larger one. That's crazy. Emma Watson, any Harry Potter fans? Hermione Granger's right here. She looks pretty similar as well. Selena Gomez. What's her last one? Leonardo DiCaprio. His face is pretty symmetric. I mean, look at that, you guys. His hardly changes. I think he's probably the best for guys, and I think Rihanna. Let's go back to Rihanna quick. Yeah, hers, like, I guess her eye moves a little bit. But, anywho, again, symmetry. There we are. Let's go back to our note sheet here. Notes aren't very hard. It's almost kind of like too easy. But that's okay. We like easy things, don't we? So, we have 3 different types of symmetry that we'll see or look at today. The first one is line symmetry, and that's kind of what we were just doing with the celebrity faces. Can we draw a line anywhere on our object that would map the image back onto itself? So if I go like this, do we agree that this left side here is a mirror image of this right side here? Yeah, we would. So that would be line symmetry. Again, think of a mirror image. Point symmetry. A figure has point symmetry if the image can be mapped onto itself by rotating it 180 degrees. So, essentially, could I put a dot in the middle of my figure, take it, and rotate it 180, so I just essentially turn it upside down? Do I end up with the same picture? I do here. So, it's easy for me, because I can make a copy of it. So here's our original picture right here, this N. And if I take this N I copied, if I turn it upside down, do I end up with the same picture? Yep, we sure do. Now rotational symmetry is kind of like point symmetry, but the difference is for point symmetry it has to be 180 degrees, or turning it upside down, whereas rotational could be any amount of degree and still end up with the same image. So again, I'm going to put my little point on here, and I'm going to turn it this way, and we're going to see if I can end up with the same sun. So if I'm rotating, 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 do you guys see how I rotated it? Oh, I don't know, like 70 degrees, and I still end up with the same picture here? So that is rotational symmetry. And now, folks, we just have a bunch of examples of practicing the same old thing. Okay? So let's look here. We'll just kind of go down the line and just decide, does it have line, does it have point, or none of the above, okay? So this guy, can I draw a line anywhere? I could just have to draw one. There could be multiple, but can I draw at least one that would map this hexagon onto itself? Well, sure. I could go this way, and that would map it. Or you could go this way, and that could map it. So line checks out. Point, remember, can I turn it upside down and end up with the same image? Yep, sure did. Rotational. If it has point, it has rotational. So, there we are. Okay, let's go on to number 2. Can I draw a line on this triangle? I certainly can, right down the middle, and it cuts it directly in half, so that works. Point, can I turn it upside down? Sure can, but do I get the same thing? No, so it does not have point symmetry. But does it have rotational? Could I still turn this and get my picture without going all the way around? Yeah, so let's go back a second. I started here. I'm going to keep turning until I end up with the same picture. Yep. I went about 120 degrees to get that picture, so it has rotational. Okay, let's look at 3. Can I draw a line through here? We always want to be like, yes, I can draw it straight up and down, or I can cut it in half, but if I were to fold that on top of itself, these points wouldn't match up. I know it's kind of hard to see, so this one does not have line. Let's see if I can turn it 180. Can I go 180? Yep, sure did. And remember, if it has point, then we know it has rotational. Okay, let's check for number 4. Does it have a line? Can I draw a line anywhere through here? Nope. No line. Point, can I turn it upside down and get the same thing? Nope. And then can I keep rotating it to get the same image before I make it all the way around 360? No. So this one is none. Okay, let's try the star. Okay. Can I draw a line? We sure can, right down the middle, so that checks out. Point, let's see. Can we turn this star upside down and get the same star? I went 180. Do I get the same image, you guys? No, I don't. But now let's see if I can rotate it X amount of degrees so I end up with the same star. So let's see here. I'm rotating it, rotating it, rotating it. Oh, don't those look pretty much the same? They sure do. So it does have rotational. Okay, number 6 is a goofy one. So let's see line. Can I cut it in half this way? No. Can I cut it in half this way? No. Can we try to do it diagonally? It appears like it would work, but look, you guys. I would need something to match this right here, and it's blank. So no, it does not have line. Let's click it and see if I can go 180. Went 180 for point. Does it have point? Yep, it does. Check it. And remember, if it has point, it definitely has rotational. Okay, let's look at the letter A. Let's cut it down the middle. Yep, it has line. Let's check and see if it has point. Can I go 180? No. Do those look the same? Nope. Okay, let's start back up for rotational. Can I turn this any amount of degrees to end up with the same picture before going all the way around? Nope. So it just has line. Okay, what about this lightning bolt? Can I draw a line anywhere through here? No. What about this way? No, doesn't work. So no line. Let's check point. Can I turn it 180 upside down? Do I get the same picture? Negative. Okay, now we're just going to go all the way around and see if I end up with the same thing at any point before. Negative again. So this one has none. Let's check out this little windmill looking thing. Can we draw a line anywhere on here? It looks like it is, but no, we can't. I can't go this way. That doesn't work. I can't go this way. If I try diagonally, it also does not work. So it does not have a line. I can't draw a line anywhere. Let's see if I can turn it upside down and end up with the same picture. We get the same thing? We certainly do. And remember, if it has point, it has rotational. Number 10, line, we could go right down the middle, right? And that cuts it in half. Point, let's turn her upside down and see what happens. Yep, get the same thing. So then it has point and rotational. R, can I draw a line anywhere on here? That way doesn't work, doesn't work, doesn't work, doesn't work. So no line of symmetry. Let's try point. Can we turn her upside down? Nope. Now let's see if we can go at any degree around the circle. Do I end up with the same original R? I hope you're getting what I'm getting, and that's a big old no. So none. Check out 12. Line symmetry. Yeah, let's look. I can go this way. That cuts it in half. So it does have line. Let's check our point. Can I turn her upside down? It looks pretty similar, but are they the exact same? And that's a no. Okay, let's keep going to see if at any point it looks the same for rotational. And that is, nope. So just line on that one. Okay, 13. Let's check this guy out. Let's see line. Can I cut down the middle? Yep, line works. Okay, let's check for point. Can we turn her upside down and get the same picture? 180, I'm upside down. Do those look the same? No, so no point, but let's check rotational. So can I, oops. I'm gonna keep turning until maybe I end up with the same image, and I think it will, guys, look. Those are the same, aren't they? And I'm not all the way around my circle. So at about 120 degrees we turned it. Okay, let's check Z. Can I draw a line? No, no, no. So no line. Can we turn this guy upside down and the same Z? Hey, we sure can. So if it has point, we know it has rotational. Okay, you guys take the next, I don't know, pause the video 40 seconds to try those last 6, and then I'll quickly go through them real fast. So you guys do these 6 real quick, pause video, and then we can join back together. I just want you to kind of think for yourself, because sometimes it's easy just to copy and not really digest what's happening. Okay, here we go. Little shamrock guy, does it have line? I hope you put yes, right? There's a few, it could go that way or that way. So line works. Point, could you turn it upside down and get the same picture? Yep, they look the same to me. So if it has point, it also has rotational. The Queen of Hearts, let's see. Does it have line? When it's this detailed, it's almost always going to be a no, you guys, because every little thing would have to map to something. So this one's a hard no on the line. But let's see, can I turn it upside down and get the same thing? Yeah, I think so. That looks pretty good to me. So this one should just be point and rotational. 17, this is a wonky figure, 1, 2, 3, 4, 5, 6, a 6-sided figure. We'd actually still call this hexagon, even though it's not a regular hexagon, fun fact. But we can obviously tell there's no line. I could draw no line on here. Can I turn it upside down and get the same thing? Nope. Oops, I don't want to do that. And then from here, if I keep going, do I ever get the same thing before I get all the way back to the top? And that is a no, so this has none. We have this boomerang looking thing. For line, you could cut it that way and it would work, so line works. And that should be it, because if I turn it upside down, it's close to the same thing, but it's pointing in opposite directions. And again, if I keep going, I would never get the original image before I make it all the way around the circle. So it just has line. Okay. And now we have 2 left, this recycle symbol. Is there line symmetry anywhere? No. Guys, no matter where you try cut it, you're not going to get the same on both sides of that line. So no line. Check out point. Can I turn her upside down? Nope. But this one's kind of the weird case where it is rotational. So if I keep turning it from the original, and I go, again, about 120 degrees, do you guys see how these map onto each other? Same thing. And then our snowflake, our beautiful snowflake, right? You could cut this in many spots in half for line. I just went that way, so line works. Point, can we turn her upside down? Woo! We sure can, and if it has a point, it has rotational. Thank you, kids. Mrs. Kwame will be able to help you. If you have any questions, please be good for the sub. I will see your bright, shiny faces tomorrow, and you have a good rest of your day.